This is the design group that will restore the natural runoff and water quality to our campus.
LID stands for Low Impact Development and is a sustainable practice that implements BMPs, or best management practices, to help reduce runoff from impervious surfaces, improve water quality, and restore the natural hydrology of the land.
Living in such a unique area, our design team had to take into consideration climate, elevations, soil types, and as well as the fact our campus is located on a body of water.
Currently, all the stormwater runoff is directed into storm sewers that flow into this water body. This is a problem if the runoff is carrying sediment or pollutants that can damage aquatic ecosystems.
Initially, our team had to take soil samples, water samples, as well as compare the current and natural hydrology conditions using the NRCS curve number and alternating block methods.
There were 7 types of BMPs proposed for this site: cisterns, bioretention ponds, check dams, green roof, infiltration trenches, sand filter, and a retention pond.
We plan on putting a cistern in this building. Well, it will be able to hold 1,500 gallons of rainwater and it'll also be able to water the nearby landscaping.
This is just one of the many locations for a bioretention garden. These gardens will be able to store and treat large volumes of runoff. They will also be planted with native vegetation that will help encourage pollinator diversity on campus.
Check dams will be used on our upper campus to reduce erosion and allow sediment and pollutants to settle out.
A green roof like the one shown here was designed for a 5,200 square foot building section. This new roof will provide insulation, heat island mitigation, as well as reduce energy costs and roof runoff.
This is one location for an infiltration trench. This trench will be filled with karst limestone, creating a reservoir for water to soak into the ground easier. It will also provide high pollution removal.
A sand filter will be located here and will be our best method for removing solids and vehicle pollutants from parking lot runoff.
A retention pond will be located here. This pond will not only be cost effective based on water storage, but it will also provide aesthetics to campus and encourage wildlife activity.
After installation, it is important to educate the 9,000 site users on LID value to campus by creating programs and educational signs for each location.
The life cycle costs for each of the 24 stormwater BMPs have been calculated and ranked in order of cost benefit. This allows for easy implementation by the university, who has already expressed interest in making this project a reality.
So to summarize our entire project, we have 24 individual BMP projects on campus that restore the natural hydrology and water quality for 91 acres of impervious surface. They will disconnect 4,500 square feet of impervious surface, reduce peak flow by up to 0.2 CFS, reduce landscape irrigation by 30,000 gallons, restore 30 acres of native trees, restore 2 acres of natural vegetation, add value to the campus for 8,000 people, and educate the community.